developer. I'm the guy who liked Steve Jobs that time back. All right, so thank you for the opportunity to be here with you today. Today I'm going a little bit to talk about my story with Gratex. It's going to be a little bit personal. Gratex is a company which is on the market 25 years, and last 20 years we work in insurance business. My name is Michal, and I'm responsible for the development of the solutions for our customers, which are UK and Australia underwriting agencies, or if you like, small insurance companies. Motivation for this presentation. The presentation topic is parallel projects and development in parallel projects environment. Okay, so now I have to tell you what happened to me. They came to me and to my team and said, here is a new customer, here's a new agency in Sydney, create a system for them. And they came over and said, there's a second company. They want the same. It's an insurance company, they want the insurance system. Then there was a third one and fourth one. What happened to us is that we copied four first solutions. So, okay, we tried to reuse some code, but there was a sharp time plan, and what happened to us that we ended up with the 4 instances, with the 4 different code bases after several change requests for each project. And all 4 needed to be extended, maintained, and bug fixed and documented. And in that moment of depression, they told to me, Michal, there are going to be 20 more. So we had to stop and rethink things, how we build them. So in our team, we have given us a very simple task, which is not easy to achieve, which is to develop common features once and share them between the customers, between the solutions. So we need to somehow share the code base. We need to build flexible components that can be easily extended, then we can extensively reuse in the descriptive manner, like, okay, this code, because that's what customer says, or our business people says, this is the same solution as this one that you developed 2 months ago, but here are the differences. So we need to find out solutions, how to write code this way, how to describe differences and reuse the components. The domain is insurance, so the screens are, or the workflow is very similar, the components are very similar, but they are not the same. It's mostly about the workflows. And there are plenty UI components that can be somehow not coded manually. So that we found out a way how to generate user interface components based on the definition of workflow. Also, there are a lot of tasks in the development which can be done by people which are not developers. So we try to join business people into development process. And because we have multiple customers, multiple projects, we need to unify somehow the development environment, use the same tooling and same layout. So I will start to talk about the first one, how we share the source code. Okay, so there is some common source code, so you put it into different Git repository. That's quite obvious, and then you can link it with your projects. Okay, so yellow rectangles are project repositories, and blue ones are branches. But there is one problem, which is isolation of change. I cannot provide new version of core component and force others to adapt at the moment when I create new version. So this is more about the process, how to work with Git and with submodules. So what we found out as an effective way is that each project has a dedicated branch in the core repository, And if this customer and this project needs new feature, which is potentially to be reused later, he contributes to his dedicated branch of the core. When it's bug fixed and working perfectly, it's merged to the big domain, and other projects can pull those commits on demand when they want, when they can, based on their time plans. Okay, so this is how we found a way how to efficiently work with the Git repository and how we share the codes. Flexible architecture and flexible components when using about the data modeling. I just want to shortly describe what's the traditional way and how we do it. I don't say that's the best way, but how we do it. Traditional, you define your Java model, for example, if you choose language Java, at the level, at the top, you need some schema validations, you need some, when the request comes to the server, you need somehow validate whether this request is correct, and you can proceed with business logic. Then when your business logic calculates some extra data, you want to store in the database. If the database is a relational database, you need to do some object-relational mapping. So there are like 3 artifacts which you need to touch when you change something, when you or when you introduce new part, new structure, new model. We are doing it differently. We are JSON-based. We have a JSON-based architecture. So, okay, all right. Here's a JSON schema validation at this layer. Now, what if we choose the language in the middle, which doesn't necessarily need to create the internal Java model or representation of the model? What if we like hacking and scripting style of development? So we choose a groovy scripts for the middle business logic, which doesn't necessarily need to create the internal model at all. It's just tree structure of maps and lists. So I will show you later. But this is a challenge, and also the storage in the database is a challenge. So if we need to write the JSON schema anyway, why don't use some JSON schema-based metadata model, which can be interpreted as a JSON schema for validation of input, and also can be interpreted as a validation of the result of the business process layer before it is stored into database. And what if we can, as a side effect, use this kind of data as a base for generation of the documents data model? So this is what I'm talking about. So this is a simple structure. As you can see, the language is very similar to the JSON schema language, but this is written in the Groovy. So you have a structure. This object has a properties, quote date, code expiration, and some inner properties down there. You can see that they have already provided the description field with the textual description what this field is good for. This is an example from the real big projects. You can join multiple files. It's very nice because everything is a method. You can call another method from the middle, which describes some substructure which is placed in a different file. What's more important, you have an imperative hack in the code where you can adapt and recreate the new structure based on the existing one. Look at this. I can clone the original structure, I can remove this field, and at the end I can introduce new field in the middle. So I don't need to, I can, this way, this is how I cope with the exceptional cases. Do you know what the exceptional cases are? You created your great data model which can cover 95% of the cases, but there are still those 5 that are exceptions. So now I can take the 95% good model and a little bit recreate it. I can also use this approach when we are talking, as I was talking about this validation. Because what's happened here? Some data are coming here to the server, business logic calculates some rest, and this business logic mostly retransfer the input to the form which is stored into the database, or yeah, this is the case. So I can define this model and I can define this model imperative way. I can remove some fields which are not part of the input but are calculated by the middle layer. And that's what we do. This is an example from the real project. Okay, business logic and development in Groovy scripting like hacking. You can do something like this in your business logic. You don't need to use types. You are still inside the Java virtual machine. You have because the Groovy language is hosted inside. So you can have an object. You can add fields. Okay, this is a school example. This is a project example. So you have a calculate premium, poistné in Slovakia. There are two input parameters, quote, product definition, and you can enrich your quote object with some calculation formula, which is pretty nice, readable. And I don't care if I do a mistake here. If I do a mistake here and the data which I produce by my Groovy script doesn't fit the database schema, it will raise 500. If server is requested with a payload which doesn't fit the input schema, server raises 400 exception. And this is more examples from the real project. Okay, how to refactor this kind of code? Yeah, because you don't have IntelliJ, maybe you don't have Eclipse. You are a pretty cool dynamic. You don't have an internal model. How you can refactor? Well, you have to write tests, but you have to write them anyway. So we have full or 90% coverage of all cases. So I will show you this short video. We are using a Mocha testing framework, which is based on the JavaScript, so again, scripting. So those are the server's logs. This is a list of tests. This is a database consistent check, so I can, when I evaluate, I can see whether some test spoils some data or not. And this is my workstation. So tests are must. We are using a Mocha framework, which is a component which runs in Node.js. What kind of tests we write? We call them internally onion helicopter tests. Why onion? Onion has layers. So you need to, if you want to create some sophisticated test, you have to prepare data for it. You have to prepare the layers of the onion. There is a first test which creates a policy, poistná zmluva, in status initial. There is another which takes this, and based on, at the top of that, there is created another test which executes some workflow actions on it, and it creates it in status quote completed and policy invoiced. Once I have a policy invoiced, which is, for example, this one-liner here in this test, I can do my sophisticated testing. I can request for the list of finance entries related to this policy, and I can maybe do some asserts. I have a 12 installments assert here because it's monthly paid policy, for example. We also build some components which can shorten the number of lines to test some parts. So there is some workflow utils, for example. There are some finance API, which, what does it do? Firstly I create the policy in status invoice, and then I assert that first and seventh should be posted to the not yet due, and others to the due account when we are talking about double entry bookkeeping. Yep. Flexible architecture and generated user interface based on the metadata. Let's take a report. There is a plenty of reports in the system. You don't want to create the screens which will prompt user to pick the criteria of the report. You don't want to do that. It's waste of time, because those are the very straightforward screens. They can be interpreted by something like this, for example. Request parameters for the report are those which should be displayed as those UI components. What's the nice part of it? You can have a single file for a policy data dump report, for example, which includes every necessary information. Which are the request parameters? How are they transformed to the database query? And then execution of the database query. And at the bottom, the visualization in CSV or Excel based on the output type. Okay, we are in the finance domain, so bank account statements. Again, each bank has its own bank account statement format with different columns. Again, this screen can be generated based on the CSV structure. Workflows. Why should we manually implement screen like this? This is a workflow. We are in the status. Initial document is already generated, and there is an action, quote completion. But before system is completion of this business logic is executed, we need to review the document. So we internally call it follow-up feature. So there is a follow-up. In order to continue, system requires user to provide some additional information. So there is a one-liner which will cause this if somebody hits the quote complete button in the workflow. This, sorry, timing, right? Timing. Yeah, I have always problem with timing. I will do it very short now. Most other examples, if you require 2 follow-ups, you can have this kind of nice wizard. Posting configuration, this is too complex. I will be here. You can ask me. Okay, you can configure how systems should create accounting entries into the database based on such templates, which is very, readable. Or also, account manager can do it, or accounting manager, accounting-related person. Well, what's the point here? That we can configure our system in a lot of ways. We can configure algorithms which are custom for the project outside from the core and call it from the generic algorithms. That's what we do. We can define the structures. We can define the report menus in this. I will skip this one. What I want to say, we are programming declarative way. We are finding ways how to write the code the way that should be interpreted by many generic codes. For example, document generator. Document generator can take all data model definitions or workflow definitions and create nice UML diagrams with description of each field, a nice status diagram related to each workflow, data structure, accounting configuration. Everything was created on this keyboard. And using this screen, yeah. Conclusion. This is the final one. Okay. So we are trying to write the knowledge at the one place and in the form that can be reused in other parts of the system for JSON validations, for validation before it's stored to database. We share common features via Git submodule, but it's most about methodology, not about tool use, but about the methodology and the discipline inside the team. We build flexible components, and we do lightweight scripting style development because modern technologies allow us to do. We use functional programming and declarative programming, which enables us to create a huge configurations and customization features. We generate documentation from the executable code. Our domain is insurance. Our customers are insurance companies. There is no waterfall model of development. It's not needed because developers became in a very short period of time domain experts and can directly write the declarative code based on the requirements documents from the customer. And thank you for your attention.
Thanks a lot, Michael. This was more technical, so I believe there are developers or guys who can find this interesting and useful. Now we are going to present more, let's say, real life technology which can help. Yeah, it was here, which can actually help retailers in their physical shops. Have you ever went to a shop and you had a problem finding, for example, in grocery, particular thing? What do you think? What it means for retailer with physical shop to analyze the behavior of his customer during the time they spend in it? What this can mean for a financial institution or a bank? Mr. Marian Holler is going now to tell you more about the idea of Pygmalios. How does it work and how it can improve numbers for the retailers' physical shops. I'm just going very quickly to plug in and you can introduce yourself.
Hi, so I'm Marian, I'm from Pygmalios and I'm the VP of product there. I can start without the presentation with a quick history of our company. So it was founded in 2014 when our three founders thought about tracking of materials and physical presence of people in retail, and it was in time when there was no such technology present. They were starting with iBeacons for in-store tracking, and so the guys applied for a business idea of the year and they won. So the Pygmalios was started. Okay. So it's a PDF and it's not the best way to present, but so nowadays we are a provider of in-store analytical software. We have 30 plus clients with 400 stores and 100 proven business cases. What we do actually, we do, you can imagine it's something like Google Analytics, but for retail. So what we do, we track customers' behavior. We know, we can tell you if there is a queue creating behind the counter, or we can track specific zones. And now I will show you a small video, short video about the technology. Oh, sorry.
Pygmalios Customer Experience Analytics provides a complete platform for answering a simple question: what's actually happening within my retail environments? With browsing, we're able to see exactly what happens when a customer enters your store. Our technology allows you the ability to track individual footpaths of customers and understand which parts of the store are most engaging for your clients. This helps you answer important questions, like whether or not your store is designed optimally, or whether or not customers are spending time in your stores in the manner in which you expect. With traffic, we're able to give you an exact picture of how often new and returning customers interact with your stores. With people counting, we're able to see the number of people not only entering and leaving the store, but the amount of time that they spend in the store overall. This helps us understand whether or not marketing campaigns were effective in getting new visitors to come to the store, or whether or not opening hours have been set correctly according to the number of people walking outside the store during the day. This provides data into understanding how to effectively staff your stores in order to best meet customer demand. Demography gives you deeper insight into understanding the age range, gender, and emotions of your customers. With automatic gender and age detection, we're able to understand whether or not your customers' demographics have changed over time. You're also able to quantify how effective you are in reaching target groups of marketing campaigns and understanding how effective they were at driving sales within your individual stores. Q Analytics helps you see the number of customers in line and how long they wait to check out. Q Analytics provides not only an idea of customer journey, but how likely customers are to be satisfied with their experience while queuing. By combining both real-time and historical data, we're able to help you predict what would be the ideal times and best ways to staff your stores in response to customer demand. Ultimately, we're able to combine this data to help you understand how queue length affects customer loyalty, number of transactions, and frequency of purchases.
So now you see new visitors by hours in a week. You can see the punch card. Now you see occupancy by days and hours. Now you can compare the occupancy outside visitors traffic with visits. And you can see occupancy with visits. Okay, so that was a short video of our technology. And you can see all that. Sorry? Sorry for this.
Pygmalios Customer Experience Analytics provides a complete...
Okay, so I will continue. So this is a short overview of the architecture, how it works. So basically, we got the different modules like browsing, traffic, demographics, and queue that was mentioned in the video. We collect the data from the sensors, and they are collected and processed in a Pygmalios cloud with external factors like weather and holidays. And then you can see the outputs in the reports in the analytic console, or we got customer success guys that can help you analyze the data. And also if you got your own analytics department, we can provide you with an API, so you can you can interact with the data by yourself. So since we are here at FinTech, now I will show you how we can help banks to set up the KPIs and help them to decide if they want to, for example, close a branch, or if they want to remodel or do the experience branch with the remodeling. So basically, we can help you set up the KPIs and track loyalty, track conversion. We can show you how zones benchmark with each other, or how the clerks interact with the customers, what's the dwell time of the customers. As for developers, the main thing for us is we are cloud-based, so we currently we migrate to Google Cloud. We use Cassandra, Mongo, Kubernetes, Kafka, React, Spark, and Scala. So all the new stuff. Like for IoT devices, we use a lot of sensors. Basically, we daily process around 30 gigabytes of data from 2,400 active sensors. Okay, we got the old presentation without the without the numbers, and 400 stores installed. And the main challenges for us are basically to integrate all the data and provide the comprehensive output for the customers. We use machine learning for the automatic data reports. We have also the customer success team that you can interact with to interpret the data. So if you don't have your own analytics team, we can help you with that as well. And we are 100% GDPR compliant. We take the privacy and security pretty seriously. So that's our day-to-day operations. And if you have any more questions, you can catch me after the presentations, or if you would like, you can visit us at our headquarters behind at Trenčianska, behind the Miletičeva market. For Wednesdays we do for breakfast waffles. So tomorrow at 9 you are all welcome to join us and to talk with us. So thank you.
Super. Thanks a lot. I find this really interesting. So, does anyone from the audience have a question towards Marian? Do you? No?
I have many questions, so I'll ask them later or tomorrow.
Okay.
Thank you.
You can also do it during at the bar. Grab a beer, and the conversation also goes better with beers, right? Good. Now, Michal Galik is going to tell you a little bit about interactive digital solutions. RMG Network is a leading company in the field of digital signage. They have clients from all around the world, from the Fortune top 500 companies such as Richard Branson's Virgin. They provide impressive hardware and software solutions, so I believe Michal will impress you with his presentation. Please welcome